All right, today we're going to talk about equations, and we're going to be reviewing what we've talked about previously about equations. Remember that an equation is just saying that two things are equal to each other. For example, we could say 2 plus 3 equals 5. That's an equation. I'm just saying this is equal to that. I could use pronumerals, or we sometimes call them unknowns, in an equation. We could say something like 7 plus x equals 36. That's still an equation. It's got a pronumeral or an unknown in it. Okay, but that's another example of an equation. And equations, by the way, can be true or can be false. So for example, I think you'd agree 2 plus 3 equals 5. That's a true equation. What if I said 3 plus 8 equals 10? Well, that's still an equation, but it's a false one. This is a false equation. And one way that we can fix false equations is just to turn it into an inequation, or an inequality, turn it into it's not equal to. Now it's a true statement. And equations have both a left-hand side and a right-hand side. So whenever we think about it, the left-hand side, the right-hand side, it's divided by the equal sign. And all we're saying is that the two sides, the left-hand side and the right-hand side, are equal to each other. Okay? So, let's use some examples. Let's say we had 3 plus 8 equals 15 minus 4. That is an equation. Well, the question is it a true equation? Well, let's see over here. The left-hand side is 11. 3 plus 8 is 11. And the right-hand side, 15 minus 4, is also 11. So that means that is a true equation. How about this one? 7 times 3 equals 20 plus 5. Okay, it's an equation, but is it a true equation? Well, this side is 21, 7 times 3. 20 plus 5 is 25. Those two are not equal, so that's a false equation. I could make it true, remember, by just putting a not equal there. Okay, one more example. We're going to use one with a pronumeral this time. Let's say we had x plus 20. Let's draw a line here so we keep it straight. X plus 20 is equal to 3 times x. Now we don't know what x is. It's an unknown. It's a pronumeral. But what if I told you that x is equal to 10? Well, that means I can put x in place of, so I can put it 10 in place of x. So what do I get here? 10 plus 20 is 30, equals 3 times 10, which is also 30. So we have a true equation. Now when we're working with these, particularly with situations where we have pronumerals involved, we also can do what's called solve the equation. We're trying to find the solution or the answer, the value that makes the equation true. Now let's erase a little bit of this and see if we can give some examples here. A solution is a value that makes an equation true. And depending on the kind of equation we're dealing with, we might have one solution, we might have more than one solution, we might actually have no solutions. That is possible. Okay, let's try this. 4, let's blue again, 4 plus x equals 25. Now, in primary school, we always follow equals with the answer, but now that we're in high school, we don't do that. Equals does not mean and the answer is, because what we want is not the answer, but the solution. We want the value for x that makes this true. So in order to solve this, what do we need to do? Well, we need to find a number that added to 4 gives me 25. The simplest way to do that is to say, well, adding is the reverse of subtracting, so how about if I take the 4 away? I'll just move it over here and take it away instead. I'm going to subtract it, and that means 21. So x is equal to 21. That's called solving. And I can always put that back in and see if it works. 4 plus 21 is equal to 25? Yes, that works. How about this one? 5y equals 45. Now we're not adding this time, we are multiplying. So if we want to multiply, then what undoes multiplying? Dividing undoes multiplying. So what we can do is we can divide both sides by 5. We can divide both sides by 5. So 5 times y divided by 5, that's to get rid of the 5. This 5 divided by 5 is just 1, so this makes it go away on the left-hand side. And we get y equals 45 divided by 5 is 9. And you can always take that solution, or what you think is the solution, and put it back in and check. So we put the 9 in, and we get 5 times 9. Does that equal 45? Yes, it is. Some problems will require a little bit more work. They may take 2 steps instead of 1. Let's try this one. 26 equals 3z plus 5. Now, we can either think of moving the 5 to the other side and changing the sign, or we can think of, since it's added, we can subtract it from both sides. So we'll do that this time, and we'll say, take away 5, take away 5. The 5's there go away. That's what we wanted them to do. That's why we took it away, because it was added, and now we take it away. So we have 21 equals 3 times z. That's multiplied, so we divide to make it go away. Divide by 3. And we get 7 is equal to z. That is our solution. And again, we should check it just to make sure that it works. 7 times 3 is 21, plus 5 is 26, which is my answer there. So that works. Now the other thing that we can do, as we're talking about equations, is we can think about turning word problems into mathematical equations or expressions. Let's say, for sake of discussion, that we had this. We said k is doubled, and then 3 is added, and the result is 52. K is doubled, then 3 is added, and the result is 52. Okay, what would we do? K is doubled. What does that mean? Doubled means we multiply by 2. So we have 2k. Then 3 is added. So plus 3. The result, that's a magic word that says we're talking about what it's equal to. The result is, it equals 52. And we could use this same process over here, and we could in fact solve that problem if we wanted to figure out what the answer is. Let's try something different. Let's say Alex works for n hours. We don't know how many hours he's working, so we're just going to say n hours. It's an unknown. It's a pronumeral. And he works for $12 per hour. And he earns $156. Now, we don't have any nice equals language in this one, but I think you can sort of figure that out on your own. So he works for this many hours at this price an hour, and he earns, in this case, that's our key to tell us that it equals something. It equals 156. He works for n hours, and he works at $12 for each hour. So for each of those hours, it makes $12. So that's telling us we have to multiply 12n. And this tells us he's equal to 156. And again, we could solve that if we wanted to and figure out how many hours that he worked. And in this case, if we did that, we'd just divide by 12. And we'd find out that n is equal to 13 hours. And that is how we do equations.